Hello everyone. Today we're going to learn about the combined gas law. So, previously we've learned about the individual gas laws. We have Boyle's law, Charles' law, and Gay-Lussac's law. And they show us the relationships between pressure, volume, and temperature. So Boyle's law shows us a relationship between pressure and volume. Charles's law shows us the relationship between volume and temperature. Gay-Lussac's law shows us the relationship between pressure and temperature. So, we can combine Charles' law, Boyle's law, and Gay-Lussac's law into one combined gas law. And here it is. We have pressure 1 times volume 1 divided by temperature 1 is equal to pressure 2 times volume 2 divided by temperature 2. So this is useful when solving problems that involve pressure, volume, and temperature. So previously we'd only been dealing with 2 out of the 3 variables. This equation can be used when we are working with 3 different variables in the same problem. So here's an example. If I initially have a gas at a pressure of 12 atm, a volume of 23 liters, and a temperature of 200 Kelvin, and then I raise the pressure to 14 atm, increase the temperature to 300 Kelvin, what is the new volume of this gas? So, first let's identify each of these variables. We have our equation, we need our initial pressure, P1, our initial volume, V1, our initial temperature, T1, as well as our pressure, volume, and temperature after we have changed, which is P2, V2, and T2. So P1, if we read through our example, it says I initially have a gas at a pressure of 12 atm. So our pressure initially, that's what the 1 is for, is 12 atm. V1 is our initial volume, which we have right here, 23 liters. We have 23 liters. Then we also need our initial temperature, which we have right here, is 200 Kelvin. So we also need our pressure after we change our system. So we change colors. Our pressure 2, or P2, is right here at 14 atm. Our V2 is our unknown. That's what we're trying to find. That's what it's asking us. What is the new volume of the gas? And then our T2 is our temperature after the change, which we have right there as 300 Kelvin. Alright, so now we have our variables. We have to plug it into our combined gas law. So our P1 is 12 atm. Our volume 1 is 23 liters over our temperature 1 of 200 Kelvin. Then we need our pressure 2, which is 14 atm. Our volume 2, which is our unknown, so we'll label it V2, that's what we're trying to find, over our final temperature of 300 Kelvin. So now we need to isolate our variable. So I want to get V2 by itself. So I'll multiply both sides by 300 Kelvin. And then divide both sides by 14 ATM. So now our ATM units cancel on top and bottom. Our Kelvin units cancel on top and bottom. So we're left with liters, which is a good sign considering we're solving for volume. So now we just have to plug it into our calculator. We have 300 times 12 times 23 over 200 times 14, we still have our liters unit here, let's not forget that, equals V2. So now if we go to our calculators and plug that in, I get V2 is equal to 29.57. If we look at our sig figs, I have 2, 2, 1 sig fig right here, 1 sig fig right here, and 2 right here. So this should be 1 sig fig, so we'd round up to 30 liters. So that is how we use the combined gas law. If you have any questions, please let me know.